Let's go and continue our operations on decimals. Subtraction follows the same rules as addition, and it comes from the fractions, right? Being able to see fraction arithmetic converted in decimal arithmetic, and why decimals are much easier to use than fractions when doing operations. But again, that's where it comes from. So we want to emphasize that again. So for subtraction, we're not going to use the fraction approach, but I just want to make sure you're aware of it. So subtracting the first one is done over here. Here's A. You could see over here what we have. You line up the decimals and just subtract. That's it. Remember again, that lining up of decimals is because we want to get a common denominator. Now, this one, 13.3, we need to add some trailing zeros and then subtraction. Now, we have to borrow or regroup in this case, so it's not always an easy task to do that. So we need to turn that to a 10. 10 minus 2 is 8, right? And if we're going to use the remember old timers approach, you could put a 1 here. I'm going to subtract 1. Now let's just go standard, sorry. 10, and that has to become a 2. So 10 minus 7 is 3, but now I can't subtract, so I need again from that. That becomes a 2. 12 minus 5 is 7. And then I can't subtract there, so then it's 12 minus 8 is 4. And that number makes sense. 13.3 minus 8.5 would be around 4 point something. That makes sense, that difference. Another quick way we could have done that is turn that 13 point, that one, subtract, like in your mind you do it, subtract 1/10 hundred thousandths and turn it to that. And then you, from the 8.572, right, this using compensation, subtract to that, and that becomes 71. And then you could subtract 9 minus 1 is 8, 9 minus 7 is 2. Now it becomes a little bit easier. 12 minus 5 is 7. So we're back into that 12 minus 8. So you end up with that same answer. Sometimes it's a little bit easier to do mentally when you can do that, but that's subtraction. We move to multiplication, and we had seen over here too earlier kind of the process of what we do, and then you count your decimal places, right? 16.6, which made sense over here. So of course we have an algorithm for that, but again, where does it come from? It comes from fractions. Take a look, 0.7 times 0.08. That's 7/10 times 8/100. 7 times 8 is 56. The denominator becomes 1,000, and then remember, we move the decimal to the left 3 times, or we just know the number is 56 thousandths. So we don't move it, we just know that's the decimal. That becomes the shortcut, right? Moving the decimal, but we know because it's from the denominator. So the algorithm says ignore the decimals and just multiply numbers. 7 times 8 is 56. And then move the decimal the number of places. Have 3 decimals, and then you move the decimal 3 places, right? You get 56. Once you have 56, you go 0.123, right? 0.56. And then here, the way we would do it again, you would just multiply them and count the decimals. 1, 2, 3. So that's the algorithm. And so one practice run of changing to decimals, not that we would, or we would end up using a calculator too. 2.34 is 2/34 hundredths. 1.2 is 12/10. So notice when we do the fraction arithmetic, we multiply just the numbers, right? We ignore the decimals, and you end up with 2/34 times 12 is, right? That's what we could do. And then you have a denominator of thousandths, and now I know it's thousands. So you would end up with that. So again, looking at the algorithm here, ignore the decimals and the factors and multiply the 2 factors if they were whole numbers. That's what you do. That's it. And then count the number of digits. I'll allow you to read that. But you can then see how this works. 234 times 12 is 2808. 3 decimal places. You move 3 decimal places because there's 3. Right? But remember, that comes because it was the thousands there. Let's just head through this. Let's get through division. Let's see, make sure I can. Now let's stop there. We'll do the last one on division.